Okay, so I was just starting on these limit laws and the addition law, and any of these rules, these limit rules, the condition have to hold that these limits exist. And we were just showing that the addition law, that if the limits exist, no, it's not even right. Perfect. Let me pause. Okay, so addition law, we know if we can take the limit as x approaches a of f of x, that exists. Limit law as x approaches a of g of x exist. Then we can break it up. If we're looking at the limit of the sum of both of those, then we can break it up as a limit of the first plus a limit of the second. Subtraction law follows pretty much the same way. If both the limits exist and there's subtraction in between the two functions, and we're looking at that limit, we can look at the limit as x approaches a of the first function f of x minus, and then looking at the limit as x approaches a of g of x. This constant law, basically, if you have some coefficient, a number in front of a term with a variable, we can pull that coefficient out and then take the limit and then multiply that limit by that coefficient, that constant. So again, our limit has to exist as x approaches a of f of x. And then if we have that limit where we have some constant c times f of x, we can say this is the same thing as c times the limit as x approaches a of f of x. Multiplication law. Again, both of our limits are going to exist. If that condition is met, and we're looking at the limit of multiplying those two together, then we can say, well, then that's the same thing as looking at the limit of the first function times the limit of the second. So same sort of principle with division. If you have a limit as x approaches a of f of x and limit as x approaches a of g of x, they both exist. We have to have one extra condition there because we can't have the denominator go to 0 or equal to 0. It's undefined there. They both exist. Denominator is not equal to 0 as x goes to a. Then we can say, well, the limit of a quotient of f of x over g of x is the same thing as a limit as x approaches a of f of x, then divided by the limit as x approaches a of g of x. The power law. So if we have n as an integer, so remember integers were kind of like whole numbers or whole numbers with a negative in front of it. So coming from negative infinity, dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, dot, dot, dot. Those are your integers, just kind of review real quick. And the limit as x approaches a of f of x exists. Then if we were looking at the limit as x approaches a of f of x raised to some integer n, we can actually pull that exponent out and say, we can first look at the limit as x approaches f of x. Once we find that value, then we can raise it to that exponent n. Root law is almost identical to the power law. If you recall radicals, another way to rewrite like the square root of x, recall we could rewrite that with a rational exponent. That was the same thing as x to the 1/2 power. So it's basically saying the same rule as above. If we have a limit that exists and the limit is positive, if n is even, we got to be careful because we can't have negatives underneath a even power radical. They're imaginary numbers. And then we can say that the limit as x approaches a of the nth root of f of x. We can instead first take the limit as x approaches a of f of x, and then after we find that limit, we can take that nth root. So these are pretty much the laws that are going to help us do direct substitution when we're looking at limits algebraically.